Hi, and welcome to the demo for installing Ondat on SUSE Rancher via CLI. My name's Andy King, and I'm a Partner Solution Architect at SUSE. And doing the Ondat install is Rodney Karemba from Ondat. First, let's log in and select our Ondat demo cluster to view the current setup. Now we're viewing the Ondat Kubernetes cluster provisioned by SUSE Rancher for the demo. Let's look at the architecture components, Rancher nodes, and view that no persistent volumes or storage classes exist. Now I'm going to download the kubeconfig file and pass it on to Rodney to have access to the cluster to deploy Ondat operator.
We're going to check the health status of the nodes and pods before we prepare to deploy Ondat. The next step will install a local path provisioner to provide local storage to Ondat's embedded entity cluster. We'll then check that the local path provisioner has been deployed successfully. Thereafter, we're going to conduct pre-flight checks against the cluster before attempting an Ondat deployment. This may take some time depending on your cluster. Thereafter, we're going to define credentials that will be used to manage Ondat. Once defined, we're going to install Ondat and also include an embedded etcd cluster in our SUSE Rancher Kubernetes cluster. This will take a few minutes to complete. Once the installation is complete, check the health status of the Ondat components to ensure that the deployment was successful. We can also review the Ondat deployment in the SUSE Rancher UI. The deployment section will show all of the details of the Ondat components installed as deployments. The daemon section will provide details about the status of the Ondat daemon set that runs on the worker nodes. The pods section will provide details of all the pods related to Ondat components installed. In the storage section, we can see that there are 3 persistent volumes and 3 persistent volume claims for the Ondat etcd cluster that has been created using the local path storage class. We can also review the secrets created for the Ondat components that have been deployed. Configuring Ondat. In the next step, we're going to apply custom labels against the worker nodes to configure the topology-aware placement feature from Ondat. Then check to ensure that the nodes have been labeled correctly. We are then going to create a custom Ondat storage class that enables 2 replicas, tap, which is also topology-aware displacement, encryption for volumes. We're then going to mark the custom storage class as the default storage class to be used in the cluster. In the SUSE Rancher UI, you can also review the new storage class created by going to the storage class section and selecting the storage class page. The next step is to deploy the Ondat CLI as a deployment to manage Ondat. In addition, we'll make note of the pod name for future reference. Deploying a stateful application. In this step, we're going to create a namespace called MongoDB and deploy the Percona MongoDB operator. And then create a MongoDB stateful workload and ensure that it is successfully deployed. We will then get the PVCs for the stateful workload created using kubectl, and then make a note of the PVC name for future reference. You can also use the Ondat CLI to also get the volumes created for the stateful workload, and note where each volume resides on the nodes. Check the PVC used with Ondat CLI to see where each volume is located. Note that the master volume is located on the worker node 1. Demonstrate high availability. To demonstrate Ondat's high availability capability, we're going to simulate a node failure by deleting worker node 1 where the master volume resides. Once deleted, you can check that the node no longer exists in your cluster. It may take some time for your MongoDB stateful workload to recover and reinitialize its pods on the new node. Continue to inspect the resource until it is up, and then review the same PVC using the Ondat CLI that was used in the previous step. Now note how there is a new master volume that now resides on worker node 2, and we will still continue to have 2 replica volumes, as defined in the custom storage class earlier. We can also use the SUSE Rancher UI to see the number of nodes left, which is now 7 from 8, and the deployments and the stateful workloads in the MongoDB that are still up and running. In this video, we deployed Ondat into a Kubernetes cluster in your SUSE Rancher cloud native landscape. We created a custom storage class, which enabled replication, topology-aware placement, also known as TAP, to guarantee 2 replica volumes distributed on nodes in different availability zones. And lastly, we demonstrated how Ondat can automatically detect an offline master volume, elect a new replica volume to become a master, and create a new replica on a different node to maintain the defined configuration. With Ondat and SUSE Rancher, you can create a Kubernetes native stack that ensures your critical stateful workloads are highly available and durable. Thank you.